Assalamualaikum and good evening. Today we want to present about problem Vistas to our lecturer Encik Muhammad Hamzi bin Haji Muhammad Safian. Okay, next slide.
So my name is Muhammad Idham bin Abdul Halim and my metric number is 01 DDT 19F2018.
And my name is Anabil Zulkifli. My metric number is 01DT19F2038.
And my name is Muhammad Aiman bin Abdul number matric 01 DDT 19F2028. Okay, question 1. Single mode versus multi-mode fiber optic cable. Okay, firstly, based on the core, single mode is smaller than the multi-mode core, which is the size of the single mode is 9 micrometer, while the multi-mode is 50 and 62.5 micrometer. Okay, next is light propagation. In single mode, fiber optic cable is less than the multi-mode fiber optic cable. The light propagation for the single mode is less, while the light propagation for multi-mode is high. Okay, next. And then attenuation is minimum for the single mode, while for the multi-mode attenuation is more than minimum. Next slide. And then application for single mode fiber optic cable usually used in telcos, small or medium scale company, and college campus, while for the multi-mode fiber optic cable applications suitable for short distance such as data and audio, video in LANs. Okay, next slide. Okay, next we need to find refraction angle, critical angle, numeric aperture, and acceptance angle based on the question. Okay, firstly, refraction angle. Based on the formula given, n1 sin degree for 1 equal to n2 sin degree for 2. Okay, and then for n1 is 1, and then sin 28 degree equal to 1.48 sin degree 2. And then the answer for sin 28 is 0.469 equal to 1.48 sin degree 2. And then sin degree 2 equal to 0.1469 divide by 148, and then the answer for the refraction angle, we need to cosine for the divide answer, which is cosine 0.317, and then the answer is for angle for degree 2 is 18.48. Okay, next. And then we need to calculate the critical angle for the fiber optic. The formula is cosine bracket n1 divide by n2, and then we enter to the formula, which is cosine 1.25 divided by 1.48, and then the answer is 57.63 for the critical angle. And then we need to calculate the numeric aperture in A based on the formula given. Sin A equal to 1.48 kuasa 2 tolak dengan 1.25 kuasa 2 punca kuasa. And then sin A sama dengan 0.792, A sama dengan sin 0.792, and then the answer for NA is 52.37. And then lastly, acceptance angle. For acceptance angle, we need the formula is acceptance angle equal to 2A, which is 2 bracket 52.37, and then the answer for acceptance angle is 104.74. Okay, that's all. And then this is the graphic for our fiber optic for the calculation.
Okay, so for question 2, I will explain about this. What is WDM? Okay, WDM is a wavelength division multiplexer. It is a fiber optic transmission system that uses various light wavelengths to transfer data over the same medium. This technology uses different optical wavelengths. As example, they use colors of a laser light to multiplex a number of optical carrier signal on a single optical cable. Each wavelength has its own signal that does not interfere with the signal of other wavelengths. The function principle of WDM technology is shown in the diagram at the next page. Okay, so as shown on the diagram, we can see that transponder 1 will go through the orange wavelength and will not interfere the other transponder, which is there have divide into this color, and it will follow the wavelength for each color to transfer the data. So that's all from me.
The question 3. The question is: upon passive optical network system utilize a passive splitter that take one input that split it to broadcast signal downstream to many users. Illustrate basic phone architecture, terminate diagram with different type of fiber to the loop FTTL. Next slide. The fiber optic technology is here upon to help devices success in the world of telecommunication. Talking a single optical fiber upon device the fiber bandwidth with the help of the fiber optic splitter. By diving the bandwidth into the manner upon can utilize multi wavelength for data. Next slide. Passive optical network architecture. The PON architecture consists of three main units: OTL, ONU, and ODN. OTL located in CO is the interface between PON and the optical backdown network. OLT disrupt PSTN internet and CATV service to as many as 16 to 128 end user per fiber line. Passive optical separate device and optical signal into multiple equal low power signal and distribute them to end user during downstream, and in case upstream transmission they are at power combiner. ONU provides service interface to end user. ODN connect OLT and user using optical fiber. That's all from us. So thank you.